Now the question is, probability of A is 1 by 2 and probability of B is 2 by 3. Now we know that P A union B is always greater than or equal to maximum of PA and PB. Now maximum of P and PB is PB. So that means probability of A union B, it must be greater than or equal to 2 by 3. And we know that any probability is always less than or equal to 1. That means this option A, it is correct. Now if we look at A intersection B, we can write probability of A intersection B as probability of A plus probability of B minus probability of A union B, which is 7 by 6 minus probability of A union B. Now this value will be maximum when A union B is minimum, which is 2 by 3. So 7 by 6 minus 2 by 3, and there will be 7 minus 4, which is 1 by 2. So its maximum value will be 1 by 2 and will be minimum when we put maximum value of P A union B, which is 1, which is 1 by 6. So this value will lie between 1 by 6 and 1 by 2. So that means option C is also correct. Now we look at this option B. This is probability of A intersection B naught, and it is probability of A minus probability of A intersection B. Now probability of A is 1 by 2 minus probability of A intersection B. Now it will have its maximum value when A intersection B is minimum. Its minimum value is 1 by 6. So we put 1 by 2 minus 1 by 6, it will be 3 minus 1 by 6. So it will be simply 1 by 3. That means this option B is also correct. Now the same way we can write probability of A naught intersection B. Now probability of A naught intersection B, it is probability of B minus probability of A intersection B. Now probability of B is 2 by 3 minus A intersection B has two values, 1 by 6 and 1 by 2. Now we take 1 by 6, then it will be 1 by 2, which is its maximum value, and if we put 1 by 2, then it will be this 1 by 6. So that means all the four options A, B, C, D, they are correct. Now for two events, it is given that probability of A is 1 by 4, probability of A upon B, which is probability of A intersection B upon probability of B, it is also 1 by 4, and probability of B by A, which is probability of A intersection B upon probability of A, it is 1 by 2. Now we put the value of probability of A as 1 by 4, we'll get probability of A intersection B as 1 by 8. Now from A intersection B, we can find the value of probability of B. So now probability of B will be 4 times A intersection B, which is 1 by 2. Now PA into PB, it is 1 by 4 into 1 by 2, which is 1 by 8, and is same as P A intersection B. That means A and B are independent, and since the intersection is not 0, they are not mutually exclusive. Now if A and B are independent, then probability of A naught upon B will be same as probability of A naught, and probability of A naught is 3 by 4. That's your option C. And the same way, probability of B naught upon A naught will be same as probability of B naught, and which is 1 by 2. So the correct options are A, C, and D.